We've investigated transformations and reflections. We've looked at graphing functions given, or creating graphs given a function. We've looked at creating functions given a graph. Now what we want to do is construct a function given an explanation for what's changing about our graph. For example, in problem 8, we want to write the function whose graph is the graph of y equals x cubed, so we know that we have this as a base function, but is vertically stretched by a factor of 2. So keeping in mind, our function is going to be something of the form a times the quantity x minus 0 cubed plus 0, or what I mean to say here is b and c. What we want to do is identify, again, those values for a, b, and c that would relate to this given transformation. So if we have a vertical stretch being applied, then what we would want to do is plug in a value for a, and if the factor for that stretch is 2, then our given function would be y equals 2x cubed. So our function that would normally have points at 1, 1 and negative 1, negative 1 would be stretched by a factor of 2. So we'd have a point at 1, 2 and negative 1, comma 2. So we would have a function very similar to our x cubed function, but stretched away from the x-axis by a factor of 2. In example 9, we're starting off with an absolute value function, but it's being shifted up 2 units and to the right 3 units. So what we want in this case is a value for a equal to 1 because no vertical stretch is being applied. We would want our value for b to be 3 since we're shifting to the right by 3 units. And we would want our value for c to be positive 2 to represent that shift up of 2 units. So what we would have would be an absolute value function, which would normally have its only intercept at 0, 0, being shifted to the right by 3 and up by 2. And all of the points would translate along with it, giving us that absolute value function shifted into its new position. In example 10, we want the graph of y equals x squared, but in this case reflected across the x-axis and shifted to the left by 2 units. So we'll start off with that shift to the left. In order to shift left, what we would need to do would be to add 2 to the x inside that square part of our function. And then in order to reflect across the x-axis, we would need to take the opposite of that function. So this would become y equals the opposite of x plus 2 squared. In terms of graphing, this would be our square function shifted to the left by 2 units, and then where we would normally have points stretching up towards positive infinity, now those points are going to stretch down towards negative infinity, giving us the graph of our new function. In our final example here, we want an x cubed function, but we want it reflected across the y-axis and vertically stretched by a factor of 3. So in order to get that vertical stretch, what we would be doing would be taking 3 times x cubed, and then in order to get that reflection about the y-axis, what we would do would be apply a negative inside that cubed function itself, to give us y equals 3 times the quantity negative x cubed. But we could go ahead and simplify and rewrite. Negative 1 to the third power would still just be negative 1, so we could rewrite this as negative 3 x cubed, which now looks like a reflection across the x-axis, but since x cubed is an odd function, reflecting about y or x yields the same result. What we would have then would be still our center at the origin, and instead of a point at 1, 1, we would have a point at 1, negative 1 being stretched by a factor of 3. And then also the point negative 1, positive 3, giving us that x cubed function that's been stretched vertically by a factor of 3 and reflected across the y-axis.